Alright, welcome back to Simplifying Radicals. Today we're going to do part 2, which deals with variables. Bum, bum, bum. So this is kind of a two-step process. First one, step number 1, simplifying the number like what we did in the past video in the part 1. And then adding the second step, which is trying to simplify variables by grouping them into groups based on the number of your radical. Okay, so first example. I've got 144, I have the square root of 144 x cubed y to the 4th z to the 5th. So first steps first, take a look at my 144. Is that perfect? Yep, so I get 12. Alright, so again, I'm going to approach this one step at a time. So I have x cubed, y to the 4th, z to the 5th, still under that square root. So square root, think of the word square, deals with 2, right? So I want to try and get all of these variables into groups of 2. So I have 3 x's, 4 y's, 5 z's. Because we know that when they're all being multiplied, that exponent, when we see that exponent, it is that number of variables being multiplied together. So again, I said groups of 2, so I want to find as many groups of 2 as possible. So every time I see a group of 2, I'm going to circle it. Just kind of like when we were looking at prime factors yesterday, with taking a look at simplifying my numbers. We tried to see groups of 2 because we were square rooting with my numbers, and then we brought one group out. Alright, so I still have my 12. I have one group of x's coming out. I have 2 groups of y's, which is, again, y times y, which gives me y squared. Same idea, I have z times z, which gives me z squared. But then I still have this little y and this little z. Sorry, let me backtrack. I have that little x and that little z still left under my radical sign. Alright, let's take a look at the second one. Is 72 a perfect square? Can I take the square root of it right off the bat? I should hopefully be hearing, or you should be thinking, no, 72 is not perfect. So I have to break that down. Well, we saw before that it was 2 and 36. 36 is perfect. It's 6 times 6. There's my group to come out. That's what's going to stay underneath. So we're going to leave that off to the side for a second, because more things can come with that. And then 2 stays underneath. I have x, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, it looked like originally my z's were not all under that square root. So I made my square root sign longer to make sure that you are all aware that my z is actually underneath that square root sign. If I do not lengthen that line, then I forget it's there, and then I assume all those z's are just being multiplied together on the outside. Just a problem with rewriting them. So again, I'm looking at the square root, so I'm in groups of 2's. So I'm going to circle as many groups of 2's as I can. Alright, so that 6 is still out there. I have one group of x's. I have 1, 2, 3 groups of y's, so I have y to the 3rd. I have 1, 2, 3, 4 groups of z's, so I have z to the 4th. My 2 stays, the leftover y, which is located right here, and the leftover z. Alright. Do you see any shortcuts we can use rather than writing every single variable out, taking up all that space? If so, excellent. If not, we're going to look at it with this one. We're actually going to try this together. The square root of 200. Is 200 a perfect square? Nope. But 200 is 2 times 10. Oh, excuse me, is 2 times 100. 100 is 10 times 10. There's my group. That's what's going to get pulled out. So I have 10 on the outside. Square root of 2. X to the 12th, y to the 14th. So far all I did was work on that number. Next I'm going to take a look at my variables. So if you go back for a second and you notice that I ended up putting stuff into groups of 2. It's like saying I have 12 X's or 12 people and I want groups of 2 of them. I want to group them into 2s. I want to pair them up. How many groups am I going to have? Well, you should be saying 6 groups of 2 because 6 times 2 gives me 12. So if I were to rewrite my X's like I did before, I should have 6 groups of 2, which means that I'm going to end up having X to the 6 come out. Because if I write out all 12 of those and I circle groups, I'm going to have 6 groups. So I have 6 X's come out, so I have X to the 6. Now think about your Y's for a second. So I want my Y's in groups of 2, and I have 14 of them. Think of it as people. You have 14 people and you want to put them in groups of 2. How many groups will you have? 7, right? Because you have 7 groups of 2, because 14 divided by 2 gives me 7. Well, I dealt with all my X's, I dealt with all my Y's. Here's my answer. So what I can do is I can divide. Let me type this up really quick for you because we all know my handwriting's great. I can divide exponent by type of root. So I divided by 2 because it was a square root. So I'm changing some colors and making it a little bit smaller so that you guys can see it. So essentially, I took 12 divided by 2 to get 6, and I took 14 divided by 2 to get 7. So what happens when not all the variables are divisible? Well, I'm going to reduce until I can get something that is. So I'm going to see can I take the square root of 243 and get a whole number? Nope. So I'm going to have to work this one out again. 243. Well, can I divide that by 2? Nope. So let's try 3. If I divide by 3, I get 81. 81 is 9 and 9. Ooh, that was really bad. Let's try it again. 81 is 9 and 9. There's my group. I have 9 come out. Okay, or not. Computer's being super wonky. I have 9 come out. Left with 3 underneath. So I've dealt with my whole number. So I'm going to cross them off because I've talked about them. Let's take a look at my x's. I have x to the 10th. Is 10 divisible by 2? Yes, it's 5. So that means I have x to the 5th come out. Use all of those guys. Is y to the 13th divisible by 2? Is 13 divisible by 2? Nope. But I know that y to the 12th times y to the 1st is the same thing as y to the 13th. I know that 12 divided by 2 gives me 6. So 6 of them come out. I'm left with a y underneath. Let's take a look at those z's. I have to the 5th power. Is 5 divisible by 2? No. But z to the 5th is the same thing as z to the 4th times z to the 1st. 4 divided by 2 gives me 2. That leftover z just comes underneath. So my colorful answer here is 9x to the 5th, y to the 6th, z squared, times the square root of 3yz. Alright, so we can approach the same idea using cube roots, fifth roots, fourth roots. The only thing we need to do is make sure we have our charts out so we can look at our numbers. Sorry, I gotta blow my nose. Alright, sorry about that, guys. So in this next example, you notice you have the cube root of 216 x to the 12th, y to the 18th. So you're going to look on your chart and you're going to tell me, do you see the cube root of 216? Is that possible? Yep. Okay, the cube root of 216 is going to give me 6. So I'm going to bring that number out. Dealt with that, so I'm going to ignore that for a second. Now let's take a look at my x's. Last time I divided by 2 because it was the square root. This time I'm going to divide by 3 because I have the cube root. It's telling me what it is based on that little small 3 in front of my radical sign. Can I take 12 divided by 3 and get a nice easy number? Yep, that gives me 4th. So I have 6x to the 4th. I ended up using all my x's, so I can get rid of it. Don't need to worry about it. What about y to the 18th? Can 18 be divisible by 3? Yep, I get 6. So I get y to the 6th. I used them all, so I can cross them out. So my color for answer on example number 3 is 6x to the 4th, y to the 6th. Couldn't remember if there's another example down there. Alright, let's take a look at number 4 and 5. We all know I write really big. I'm going to scoot these down so I have ample amounts of room because it's really hard to write on my computer. Or not. There we go. Okay, so in this example, we're going to look at the 4th root because I have the little 4 out front, not because it's example 4. Haha. So let's take a look. Can I take the 4th root of 256? Is that on my chart? Yep. 4. Alright, I dealt with that whole number. I took the 4th root of it. No more of it. I simplified it. Now what about my x to the 9th? Can I take 9 divided by 4 and get a nice easy whole number? Nope. But I know that x to the 9th is the same thing as x to the 8th times x to the 1st. Is x to the 8th divisible by 4? Yep, it's 2. So I have x squared come out. I have 1x left underneath. Notice I left that space so I can keep writing if need be. Let's take a look at my y's. Y to the 12th. Is 12 divisible by 4? Yep. That gives me 3. So I have a y to the 3rd here. Last one. Z to the 6th. Is 6 divisible by 4? Nope. But z to the 6th is the same thing as z to the 5th times z to the 1st. Well, can I still divide by 4? Alright, nope. 5 is still not divisible by 4. What if I have z to the 4th times z squared. Can I take 4 divided by 4? Yep, that gives me 1. And then I have z squared left. Notice how when I dealt with my z's, I couldn't just reduce it by 1. Just reducing it by 1 did not get me to the next factor, or the closest factor of 4 that I wanted to get to. I had to reduce down another number in order to try it that way. So it's not always going to be nice, easy, oh, just subtract 1. Sometimes you have to subtract 2, 3, maybe even 4, depending on what exponent or what root you're looking for. So my final answer here is 4x squared y cubed z times the 4th root of x z squared. And my last one. So if you take a look at your chart, you're looking for your 5th roots. Again, it's telling me about that nice little 5th up front. Look at your chart. Can you find the 5th root of negative 1024? You say you see positive 1024 in your chart, but not negative? Well, when you have odd roots like that, because the number 5 is odd, it's not even, it's not divisible by 2. If you have an odd root, and you're taking the square root of that negative sign, you can still have a negative number. So it's the same thing as finding the 5th root of 1024 and then just tacking a negative 1 on the out. So the 5th root of 1024 is 4. So I have that negative 4 there. So that 1024 is used. All right, let's look at my x's. X to the 15th. Is 15 divisible by 5? Yep, I get 3. So I get x cubed coming out. Sorry. Ooh, change that back. What about my y's? Can my y's evenly be divided out? Can I take 8 divided by 5? Nope. Okay, well, I know that y to the 5th times y to the 3rd is the same thing as y to the 8th, because 5 plus 3 gives me 8, right? Remember, multiplying, add your exponents. 5 divided by 5 gives me 1. Leave a little space, we might have some z's here. Means y cubed has to stay underneath. Notice the 3 is still smaller than 5. You want to make sure you've taken out as many as you can. You never want that number under the radical to be larger than whatever your radical is. So I have a 3 underneath and a 5 out front. I have my smaller number inside. We're doing good. Lastly, let's take a look at those z's. Can I take 11 divided by 5? Nope, but I know I can take z to the 10th times z to the 1st. Z to the 10th, 10 divided by 5 gives me 2, so I get z squared. Use that one up, so then my z to the 1st, or just z, comes with underneath my radical. Again, 1st power, 5th out front. We're doing good. Alright, I want you to go ahead and pause this video, and I want you to try these on your own, and then you are going to check your answers based on what I end up putting on here. Now, I'm not going to really work through these. These are yours to try on your own. I know the other ones were technically supposed to be for yourself, but I wanted to go through them because I didn't think we were quite ready to try those. So please go ahead and pause your video. I'm going to pause mine. We'll come back together and we'll check our answers. All right, welcome back. If you notice now that I have this nice little sheet blocking my answers, we're going to check these one at a time. So the cube root of negative 512 x to the 6th y to the 11th is negative 8x squared y cubed times the cube root of y squared. All right, the 4th root of 2401 x to the 6th y to the 9th is 7xy squared times the 4th root of x squared y. And lastly, the 5th root of negative 32, x to the 35, y to the 42nd, is negative 2, x to the 7th, y to the 8th, times the 5th root of y squared. Hope you agreed with my answers. If not, go ahead and see your math teacher after class. All right, that's all I got for you.